Hello, everyone. Yes, moving to session number 2, following the same topic, same reflection on the past, present, and future global collaboration. And our session is called Systems Analysis for Food and Water Security. And have started with my introduction. No. Remembering this, Natalia Fath, and I'm YSSP 1997. And I'm with the Towson University currently. And our first presenter is Carl Boettiger, who was YSSP 2009. And his student is going to be YSSP this year, YSSP 2022. Carl is an assistant professor in environmental science and policy at the University of California, Berkeley. And the title of his talk is Will Algorithms Save the Planet, and Will we regret it when they do, or if they do, when they do?
All right, thank you. I'm gonna speak out here. We're in Plugger. Shout in the back or wave hands if you can't hear me, but I think this will work. So, will algorithms save our planet? Will we regret it when they do? So, yes, I'm Carl Boettiger from UC Berkeley. We've already been introduced to the big questions. This group needs really no tutorial on the changing planet, the increase of wildfire threats, particularly in California as well as around the world, impacts on global fisheries and other natural resources, transformation in land use and feeding the planet, and changes from climate that spill over into our ecosystems, like this pine bark beetle's devastation that has survived, partly driven to a warming climate.
You might need the microphone.
Yes, thank you.
Because there's a streaming audience.
Yes, it's a streaming audience.
Aha, okay, sorry about that. I'll follow the rules now. And of course, the global pandemic, which needs no more introduction. So what do we do? So I arrived at IIASA in 2009 as a YSSPer, quickly met other sort of like-minded folk in the evolution and ecology group. And of course, IIASA has many fond memories for me, not just from the academic, but we really got into the bike commuting into the city and exploring the sites around that. So I was part of Ulf Diekman's group, originally arrived to work on evolutionary models, stochastic integrals to predict distributions in evolution, but you know that you can't go to IIASA and just work on something like that and not get sucked into the whole world of systems analysis. And so IIASA was really my introduction to that world. I learned about policy analysis, and the role of social science in understanding policy cycles. I learned about optimal control and the bridge from sort of the mathematics that I was thinking about to where it really meets the road in actual policy. And I met so many other people thinking about creative problems here at one of those sort of simulated summits we were doing there. I'm talking to Vasilis Dekos, who was coming from Martin Skeffer's group, and he just kept on talking to me about these early warning signals of regime collapse and tipping points. And even though I was working nothing on that, he just saw I was a theoretical ecologist and then we should think about that. I ended up writing my own PhD and several papers on the concept of tipping points and early warning signals. So it really just turned the whole direction of my career. But it lasted much beyond just the impact in that one area to the way that I now kind of approach my questions. And I think you'll see that as I cover some of the ways that we've been thinking about things even more recently. I wanted to highlight that my student, as Fath mentioned, Millie Chapman, is now headed over to IIASA. I think as we speak, she may be overhead. She's working with Pero and Martin, looking at some of the things that I will be talking about now in our group. Really trying to understand how these policies like the 30 by 30 initiatives that are coming out to save biodiversity are playing out in terms of prioritization and a systems approach of thinking about sort of the many fields that we need to bring together to really answer those questions well. So I mentioned tipping points. So we know that systems in ecology and many other contexts can go through these sudden shifts where here I'm showing North Atlantic cod population, which has been harvested for over 100 years. And then all of a sudden in 1992, a sudden collapse. And once we stopped fishing, it didn't come back. And so whether we can predict when those events are going to happen and how we make decisions about those really non-linear changes really captured my imagination first at IIASA and sort of led on to my earlier work in my PhD, in other systems as well. Here, this was a paper from others looking at global scale tipping points in the Earth's ecosystem. You see one of the kind of postulated mechanisms of tipping point is the saddle node bifurcation diagram some of you may recognize, that once you go over one of these thresholds, you experience this hysteresis phenomenon where it's a lot harder to get back. So, okay, we go from those sort of simple model descriptions to our global problems, though. Those simple descriptions just don't always match up to the vast complexity we know in ecosystems that are also coupled to human interactions. And so how do we kind of bridge some of that gap? How do we make sense of all of that complexity? I'm going to talk about work that we're doing recently that is turning from our kind of classical toolbox in doing that, tools like stochastic dynamic programming, optimal control systems, where we have to reduce our models to be simple enough that we can kind of solve that vast decision space, and instead turn to some of the new tools that are emerging now from the computer science field, such as model-free deep reinforcement learning, which let us bring some of that complexity back into our optimization problems. Now, deep reinforcement learning is very simple. On the face of it, it's all you need is you have some concept of an agent. This can be a robot, this can be a human decision maker interacting with the environment. And the key thing is it's that feedback, right? That it takes an action on the environment and then it sees some observation. And so unlike other areas of machine learning that are driven by vast amounts of data, these things are trained on simulations mostly. And IIASA has a wealth of these kind of rich agent-based model approaches that can really provide the perfect fodder for training these kind of tools. Mostly the CS community is applying them in games because they're CS people and that's where the simulations are. So we want to kind of bring some of that world out into the world of the real applied problems, not just doing games and robots. So reinforcement learning, you don't need a computer to do it. You can train a chicken. It came out in the early 90s of training robots first. So this robot has no pre-programmed knowledge. It just knows it gets a reward if it moves to the right, and it's moving its motors kind of randomly, experimenting, and just by exploring this environment in that way, it was able to come up with this relatively biological way of moving forward. These days, reinforcement learning has now made huge leaps and bounds. You may have seen the stories coming out on these methods being used to beat all human players, or even better than any of the other computational techniques for playing games like chess and Go. Amazingly, these don't build in any model of the system. They're learning just by doing, just by play. So there's no pre-trained knowledge of how chess works or how Go works or what a good strategy is. You can see these getting beyond Atari games and board games in those later examples to doing things like driving cars, and most recently this past year, even controlling nuclear fusion reactions where you have to move the magnets to control the fusion blob so it doesn't escape. So they're solving really complex problems that were previously intractable, but so far not the kind of global systems problems that we think about. Here you can see an example in robots. We have started adapting some of those techniques to bring them over to complicated decision problems, starting with fisheries. So often in fisheries, we know that there are many interacting species. We know the environments are stochastic. We know that there's a complex web of interacting species involved there. And so we started building, at least can we take those models where we already know something about the truth and see if those reinforcement learning methods can make any traction on them. And of course, we can get somewhere on this. They can do just about as well, given enough time training on the simulations, as our known solutions on the simple models. And we want to be able to go a bit beyond that. Here is an example as well, applying to historical data in fisheries. It's so far, without setting these things loose on the environment, which is obviously brings big questions I'm going to talk about in a moment, it's hard to judge how well they're actually doing and how well they can go wrong. Here we're simply showing the retrospective that we could at least do better than historical fishing levels using historical data after applying a method that was trained on some of those simulations. How about tipping points? So the tipping point model is a much more challenging decision problem because the environment is slowly changing underneath you and the agent has to realize that the environment is changing. And it's a hard problem to learn because the big bad thing that happens when you go over the tipping point, suddenly it's too late to do anything about it. We tried training agents in simulated environments to that and comparing how well they would do the kind of rule of thumb conservation approaches that say, just don't get any worse, just kind of hold the environment where it is. So outcomes of that kind of steady state strategy often don't work. It often isn't enough to kind of stop and conserve where we are. because of stochasticity, because of nonlinearity. You can go across that tipping point sooner or later by chance. I'm showing some of those bad outcomes in simulations there. But the RL system is able to learn that risk and back away, put a high investment to back away from the edge when it gets near there, and then not overinvest when it's far from the edge. And this is just kind of summarizing that result, saying, yes, you can see that overall, a steady state strategy, on average, lots of collapses. The RL solution is able to avoid that. Well, those are still in simulations, though. Does RL really work? So most of the time you train it on your simulation, you try it in a different problem, and it can do rather terribly, right? Because it has learned so much specific to that one example that doesn't translate. And so you can see these seemingly impressive results, and then you go and try it in another system or in the real world, and things go terribly. I'm not sure if my videos are playing here, but this is an example of a game that RL was trained to play, in which the objective is to kind of win a boat race following the arrows, and you get these little, because it's really hard to train things with a reward only at the end, the game allowed you to get these little bonus points by picking up those fuel packets. And so RL learns to do the stupid thing of just going the wrong way around the race and just picking up these fuel packets again and again, not completing the task at all. And we know human behavior can be like that too. Sometimes you make a policy and people decide that the real incentive is to do something quite different, like you charge people for being late to their daycare pickups, and then they say, oh, I'll be late more because you put a price on it, and now it's morally okay. So both computers and humans can do weird, unexpected things, and sometimes those aren't the outcomes we want. This example, again, won't make sense because the video isn't playing, but this is one of those robots where they're training to walk, and this thing learns to walk, but it looks kind of like a cheetah, and it walks upside down on its back because, you know, it worked and it moved. And I think sometimes that is the way that we do policy as well, that we stick with something we know it works because we are afraid to explore. The trade-offs of exploitation and exploitation happen in RL just as in real policies. So why is that important? These kind of ways that these things can go wrong. Well, we're seeing just a burst in investment in these approaches to problems around the world. And they are not always being done in a systems approach, as I will highlight here. You can go to any big tech company now, and you'll find a page that they call AI for social good. And huge amounts of resources are now going into this paradigm of basically, rather than systems approach to save world problems, you know, CS is all we need to save those problems, just throw lots of CS at it. And I think that's immensely promising. There's great, excitement there, but there's also great danger, particularly if we lose that systems perspective. I'm showing on different levels. It's not just about informing the policies, providing us information. Here's in conservation examples, the way that we're using that data to drive decisions, but it's also perhaps in selecting actual policies. So examples that are saying these are the priorities and these are not the priorities. These apparently data-driven approaches are often seen as being totally objective, right? They're based on data, therefore they must be unbiased. But they're only as unbiased as the data beneath them, right? And the data is not collected randomly, but most often opportunistically. It can reflect rich world countries better than poor world countries, and it can reflect certain things while missing other context that is much harder to measure. Lastly, and quite predominantly, we're seeing algorithms involved not in making policies, but enforcing them, detecting illegal fishing, detecting illegal forestry, detecting poaching. And again, this can be a very promising development, but it raises real questions, particularly when we realize the players involved and how opaque the processes can be that underlie them. And so there has been an increasing interest from those same industries on ethical AI, but when applied to these conservation problems, it's not human data. They say, oh, surely poaching is bad for everybody, and we want to do that. Surely illegal fishing is bad for everybody. As we dig deeper into talking to our colleagues in social science, in political science, and other fields, we learn it's never that simple when you're talking about problems applied to the real world. Who's good and who's good? One avenue we've been trying to break that apart, I've been using the terminology of Luke's to say that, well, the decision maker says, oh, well, the algorithm isn't making the decision, it's just informing the decision. Well, there are different ways to have influence on power. You can be the decision maker, but you can also set the agenda, or you can have what we call world-making power, kind of set the environment in which we're thinking about the world, set what is and isn't at the table. We have seen some thinking about the way that these big algorithms are influencing sort of the side effects. This paper by Timit Guru is highlighting the environmental impact of some of these huge simulations because they're immensely costly to run. Now, I think in terms of global CO2 production, there's still a tiny percentage, but when you notice the economic footprint of running these giant models, it's not surprising that all those nature and science papers I showed, none of them were done by an academic group. everyone was done by an industry group. There is a transition in who understands and controls the levers or has access to these tools, which I think is an important question. And of course, when you start applying conservation, when the rubber meets the road, you can't say it's just about the biodiversity and aren't people involved. There's no clearer indication of that than looking in examples of conservation geographies of conflict. You do conservation in a place where there's political conflict or instability, like in Myanmar, and you find that the government there, the military junta, is perfectly happy to seize the conservation objectives as a reason to displace the militant fighters in the jungle who are resisting them and say, oh, they're in, jungle that shouldn't have people in it. And then of course they turn that jungle into palm oil. So it's a lose-lose scenario. So identifying something as a protected area can have unintended consequences. And there's other examples of this as well, but I won't dwell on them. I think the big message there is the inseparability of any of the human contexts from the non-human contexts, and attention to the resulting power and social inequality that arise when we start looking at these algorithms. Not only questions of ethics, but questions of power, of legitimacy and of accountability, of distributional equity, as well as the procedural equity. It matters how we got to the answer, not just what answer we got to. And so I think as we examine the use of these algorithms and their potential to solve these really messy problems, we have to do it in a way that embraces that full spectrum of context, including the social science and the knowledge on the ground that isn't so easily represented in the ones and zeros of our data. Thanks.
Thank you, Carl. And our next presenter is Jessica Gephart, and she was YSSP of 2014, assistant professor in environmental science at American University. And her talk is titled Shocks to Global Seafood Supply Chains.
Great, thank you. All right. There we go. Yes, so thank you very much. I'm going to talk today about some of my work on shocks to global seafood supply chain, specifically looking at some of the impacts and responses to changes initiated through the COVID-19 pandemic. This goes back though to my YSSP project, where it was really focused on modeling different countries' exposure to shocks or sudden drops in either production or trade around the world, and looking at how those might propagate over trade networks. Building on that work through other kinds of modeling, looking at these risks over trade networks, we found that in general, net importers, countries within the developing world, and countries that had low food stocks tended to be more exposed or at higher risk of these external shocks being propagated to them. And through that work, we found that countries could generally reduce some of their risk to these external shocks by increasing their production diversity, avoiding relying too much on few exporters, and maintaining some of their local production and distribution buffers. Now, as the global pandemic started to onset, a lot of people were wanting to understand what that pandemic as a shock might mean for food systems. And of course, we've seen that through a variety of ways ourselves. I'm sure everybody's heard much more about supply chains than they ever anticipated to, and bottlenecks in supply chains, and have been feeling some of those impacts. So as the pandemic began to unfold, a series of folks working in the food system space really wanted to try to understand what these impacts and responses to them were. Now, as a bit of a spoiler, it is actually not a very good shock to study because it's completely unprecedented, that everything was being hit simultaneously. And so it's really hard to pull out what was affecting which part of the supply chain, what was demand driven, what was supply driven, and how those might be interacting. Our models really were pretty sort of theoretical and based on broad structural principles and broad economic principles, but they really weren't situated to answer these questions about such a large change to so many parts of the food system. Nevertheless, though, we used a variety of really early forms of data to try to track and understand what the impacts were, and kept track of news reporting to look at some of the on-the-ground responses to those changes. So I'll talk about some of that today. We frame this work within the context of the food system resilience action cycle. And by food system resilience, we're talking about the capacity for the system to provide sufficient, appropriate, and accessible food to all in the face of a variety of disturbances. In this case, the disturbances really centered around the pandemic and the responses to that. This action cycle starts with looking at those initial short-term actions and then moves toward looking at some of the longer-term planning and responses and that adaptation to the impacts themselves. So we're really sort of still on some of that early phase, but starting to look toward what the future might look like and what kind of lessons we might be able to learn. So going across the seafood supply chain all the way from production to consumption, as I mentioned, there were really a number of impacts that were happening at every single point, some of those simultaneously, some of those interacting. So starting with consumption, there were really big shifts in the way that people were consuming food, especially early on during the pandemic. When it comes to seafood in the US, around 2/3 is consumed within restaurants, but of course, there were lockdowns across the United States and in many other countries. A lot of restaurants closed, and we saw there in early 2020 around a 50% drop in the year-over-year consumption of seafood in restaurants versus at home, with a slight uptick in that consumption at home. Now, that part corresponded to differences in how people were accessing their seafood and where those purchases were happening. One way that we were able to track that was looking at Google searches. And so this is just a sample of two classes of Google searches, where you can see shortly after the WHO announced or declared it a pandemic, there was an uptick in searches for seafood delivery and a pretty sharp rise in the searches for seafood recipes. So that really reflects that move away from eating seafood at restaurants and eating it much more at home. These changes in how people were consuming seafood really had a lot of implications for trade and distribution. So we saw here in the US in January of 2020, there started to be a really sharp decline in the year-over-year imports of especially the live and fresh categories of seafood. And so a lot of that has to do with the fact that in the US, a lot of people historically do not prepare seafood themselves a lot. They buy it purchased in fillets, breaded fillet form. And so those forms that are more difficult to prepare themselves, we had a really big drop in that. There were also logistical reasons that made that difficult, which I'll get to in a moment here. We also saw decreases in the exports. So you started to see the US turning inward, and these similar patterns were expressed or observed in other countries as well. But it wasn't just these shifts in demand that were driving those changes in trade. There were a lot of policy changes that we saw early in the pandemic that disrupted trade. So starting with in China, you may recall that when we were first learning about COVID-19, we saw that it started in a food market, and specifically, actually, the first cases were at a seafood stall. And so there were a lot of ideas about whether or not animal products were what were spreading the virus. And as a result, China restricted or banned all of the imports of live animals. This had big implications for especially some of the lobster shipments that were headed to China. Those were just cut off entirely. In addition to that, we saw them cancel other shipments of salmon and a few other products like shrimp from Ecuador. We also saw bottlenecks at different ports where there were greater restrictions to quarantining and greater surveillance, which made it more difficult for these products to move in country. That created a much higher costs because, of course, you have more product lost for these, especially for these really fresh varieties of food. And then finally, one that you might not think about, but there's a good amount of high value seafood that's air freighted, and sometimes that tags along with passenger flights. And so the restriction of passenger air flights resulted in much higher costs for some of these really high value seafood products that were being moved around the world. So those are just a few examples of the many that impacted the trade piece of it. Now, moving one step back into the processing phase, we saw a lot of disruptions to labor. And in the seafood sector itself, there were labor shortages around parts of the sector that rely on migrant labor. So up in Alaska, there's a lot of movement up there, and some of those communities did not want migratory labor coming up. In fact, they had a really bad experience that folks remembered back during the Spanish flu pandemic of it being actually migratory workers in the fishery sector that brought the flu to some of those communities. And so there was hesitancy around that. Another area where is closer to here in the Chesapeake Bay with blue crab fisheries, they rely on a lot of migratory labor. So that reduced some of the production potential. And then of course we saw that there were risks within processing facilities themselves. So you can see here on this map, these are instances of outbreaks within these processing, in food processing. So this is meat generally. And because many times people are positioned close together and working in those, working throughout the pandemic to maintain food supplies because they were designated as essential workers, we saw these high risks to outbreaks within those sectors, with just a few of the examples of ones that we observed here in the United States when it comes to seafood processing. And then when it comes to production, the production part was impacted in part through some of those issues related to labor. There were other impacts that we saw that had to do with increased monitoring at ports and making it sort of more difficult to go out and come back in. Here's a figure from Global Fishing Watch that did detect a decrease in total fishing hours there in 2022, but there was a huge variability in how impacted the fishing production sector was, in part because some had already gone out to sea, in part because some had fishing seasons that had already ended, and there were different policies when their next one began. So there were pretty big variability in it. From the aquaculture side, they tended to have a bigger problem with the inputs, so the seed and feed for actually being able to produce their products. But of course, these different impacts are still unfolding and evolving pretty quickly, but we're now starting to see how some of these different actors have been absorbing some of these impacts and reacting to these disruptions. So as we track that sort of move back forward through the supply chain, and on the fisheries side, we saw reductions in onboard monitoring, and this could have implications for some of the sustainability measures and sustainable management of those fisheries. We also saw new workplace safety measures go in place on the processing side, and across both of those pieces, we saw a lot of halting in investments, especially on aquaculture with some of these big facilities. Some of those are starting to ramp back up again though. When it comes to the distribution side, it was actually pretty interesting to watch some of the trade shift around. You saw some of these canceled shipments of fisheries products to China. The US absorbed some of those, especially for salmon and shrimp, which were a huge market for. And then as US demand started to ramp back up and China's production started to ramp back up, they started to increase their exports of tilapia to the United States. Then more on the marketing side, there started to be a shift in how people were consuming their products, especially with a turn toward more local consumption. A lot of these catch shares and local catch networks were popping up through social media and through apps, and people started to actually take advantage of these with a threefold increase in searches for some of those services. And then of course we have the consumer starting to shift some of the ways that they consume their food, and by producing at home, there's the idea that learning could create a longer term impact in how people consume seafood and shift more of our consumption toward in-home consumption here in the US. It's unclear whether or not that will stick or not, but sometimes learning can be one of those major shifts. Then of course, we've seen across all of these sectors the designation of food workers as essential workers, and the distribution of relief aid across the sector, but that has been really variable in terms of the timing and who actually has access to those funds. Now, as we move forward though, and we need to try to think about where it is that we actually want to head, which of these changes do we want to keep, and how might we build in future more robustness for future shocks. And so we can look toward past shocks to try to understand what we might be able to do. This is a review that I co-led, looking at the research on shocks or environmental shocks to the food system across the supply chain. And what you can see here is that the vast majority of work that's been done is looking at shocks to our staple crops, and primarily at the production phase. And there's been relatively little work focusing on the other stages of the supply chain. But really what we saw in happening during the pandemic was that there were shocks happening across the supply chain, and some of the biggest bottlenecks were really within the distribution piece. Part of that has to do with consolidation, the number of processors, and some of those issues related to labor and other policies, right? So there's plenty more work that really needs to be done on those spaces. Another thing that we've seen are that, yes, we're experiencing one really major shock and a few others that are politically oriented, but shocks are generally a common feature, especially different environmental shocks, and they've actually been increasing, particularly within the aquaculture sector over time. And so this is something that we're going to need to keep working on and keep thinking about. When it comes to these shocks and connecting it to trade, some work that I did, we found that in general, shocks more often correspond to changes with trade, but it's one of the biggest risks related to that is when there are export bans that can propagate those shocks along the trade network. So a lot of times these shocks tend to kind of dissipate pretty quickly, but where they usually roll into more of a crisis is when you see people closing their borders and becoming really protectionist, then you can see them run away. And that's really what we saw with the grain crisis. And then finally, when we respond to these and start to go back to engaging with fishing, we need to make sure we don't overstimulate fishery production. This has been something that's we've thought about when it comes to the relief aid, is how do we make sure that the management structures are in place, that we allow the sector to recover without undermining future sustainability. This was an observation with following the tsunami in Sri Lanka in 2004. A lot of relief organizations donated fishing gear, and that was to help the struggling fishery sector that had been hit really hard by the tsunami. But there were already concerns about overfishing in the region, and all of that additional fishing gear led to overcapacity without the management in place needed to sort of deal with that. And so you can actually see following the tsunami, there's a big uptick in fishery catch. So taking all of that work, we can see that a lot of it agrees with some of the general principles about system resilience, about maintaining diversity and maintaining sort of connectivity and sort of modularity at different levels within the system. But one thing I'll say is that a lot of that work also has been focused on some broad patterns and focused on models that look at general structures. There's a lot more that needs to be done when it comes to teasing out causality and really getting at measuring these impacts and seeing what happens, especially with actors that might behave unpredictably. And so there's a lot of empirical work that needs to be done, and a lot of work that needs to be done to look at what happens when you have some of these simultaneous shocks. And so that's really where some of my work right now is focusing on. Thank you.
Thank you, Jessica. Thank you, Carl. And we have a couple minutes for questions. Does anyone have any questions?
Thank you very much for your presentations. Observation about tipping points and shocks is a matter of perspective in terms of the time frame involved. And in a sense, casts the problem as in the context of gloom and doom. And I wonder, in looking at what I would call inflection points, whether the opportunity is to imagine solutions before through after those inflection points. So an example, for example, would be World War II. Before the end of World War II, humankind identified the Food and Agriculture Organization in 1943, the Bretton Woods and the International Monetary System in 1944, and the United Nations and International Court in 1945, and then the World War ended, and we've been implementing those solutions ever after. If we look at the context of what's going on in the world today, shocks and tipping points and so on, are we missing the opportunity to think before, through, after those moments, and to seek the opportunity to transform the system in ways that we become more resilient into the future?
Yeah, great question. I think maybe we'll both comment about just a couple words. I think you're exactly right, that there is both a risk and an opportunity in any of those tipping points. And it's worth us thinking about that kind of big picture. To just take the example of the cod collapse, it was made a bit worse by the regulation that was well designed for the most part, but tied to incentivize resilience by tying your allocation to a particular, to the cod. But that made it harder that made the fishermen invested in the future of the cod, but it made it harder for them to shift that allocation and start catching lobster, which were now going, without that predation, going much, much faster. And so by zooming out and not being like thinking of it just in that one way, we could have made that tipping point less severe. Or technology is a tipping point in the opposite direction, perhaps, and maybe we can settle that. But,
yeah, great. Yeah, and I think, so one thing that came up as we were starting to think about shocks was exactly this point about some of the subjectivity of them. And so I took about the task of trying to come up with a more statistical definition because we wanted to detect some of these shocks in time series. And as a kind of a short aside, the process of that, we'd looked at wanting to look at these drops that were greater, sort of unexpected within the context of historical variability in these time series. And so I'd kind of developed a statistical model for detecting these shocks and printed out loads of time series and sat them down with folks at the Stockholm Resilience Center and had a whole room of people circle what they would call a shock on it. And and for many, many people, it matched surprisingly well of what the model would say was a shock and what they did. But there were some folks who kind of every peak and valley, they were circling almost every point. And so it's kind of interesting because, to get exactly to your point of, people have these different interpretations of them. But the other piece that has to do with that is then we don't really necessarily consider systems that are highly variable as being a shock. So we don't pick up things like the El Nino events in the fisheries in Peru as being a shock because they're just really highly variable systems. And that surprises some people, but we might actually be moving more toward that where we have greater variability. And so that the definition of a shock becomes kind of wrapped up in us just living in highly variable systems where it does become almost every peak and valley. And so yes, I think it's a really good point, but I think there's also then tons to learn about both of these two systems.
Thank you. Really enjoyed that. Two questions from my side, if I may. The one is around the issue of tipping points and so on. And I think our common understanding is that when we talk about tipping point, talking about irreversible system change by and large. And not just shocks, it's really got to change the system fundamentally. And the question I think that Paul asked is very relevant there. Do we sit back and wait until that happens and then try and respond and adapt to that? Or do we fundamentally change the way we function and govern and the way we go about our business to prevent ourselves from precipitating irreversible systems changes to the bit? So just a question that I'd like you to respond to. If that one, and then the other one, slightly more technical, because I'm a little bit concerned about all these big corporates harnessing the social media data and the way they go about using the same data set to find multiple wonderful correlations from the same source data. And then eventually when they find these correlations. They use AI or whatever they've used to dig into this data to actually make decisions based on what's probably just correlations and not necessarily causal relationships at the end of the day. And I'm just wondering whether, in your experience, in your work, whether this is something that you come across regularly.
Yes.
Do you want to take the first question? I'll take the second.
Yeah, sure. And I think that one piece with the tipping points is that I think it can be really important to work on communicating the cost of trying to reverse those, because they're so difficult to reverse and oftentimes are not in fact reversed. There's a really, really high cost to that change that isn't necessarily realized in the present. And so when we start to imagine these futures where you no longer have this fishery or that fishery, you're starting to narrow down your food production options. You're becoming then more vulnerable to these kinds of shocks. And we have to really think about what that reduction in option value really is from a country portfolio